I'm Sarah Manteaux, and I'm going to talk about the coupling of SWAT and RIVE models to improve the biogeochemical fluxes assessment in drainage network. And I'm going to present just the methodology as I am still working on it and the issues I've encountered. So I'm working on the interactions that are occurring in the critical zone, which is the boundary layer between rock, water, soil, organisms, and air, where they interact. And these interactions are regulating the natural habitat and determine the resources, the availability of resources like water quality. So we are studying them to understand them, and because they are complex and impacted by human impacts. So to study them, there are two ways. There are observations and modeling. And in my PhD, I'm using a model to study the fluxes of nutrients, carbon, and suspended solid in a watershed, and also the role of the regulating zones in the regulation of these fluxes. It's like the role of wetlands. There are several types of models. There are empirical models that are based on observation, and the variables to explain are directly linked to explanatory variables. And on the other side, there are physically based models that are based on physical laws and are more adapted to small scales. And between them, there are conceptual physically based models that represent processes with simple relations. And it's the model I'm using is in that type. It's the SWAT model. And I'm also going to talk about the RIVE model, which is part of the Seneca River Strala model. And this conceptual physically based model needs a high amount of data to calibrate. So the SWAT model is the soil and water assessment tool. And it was created by the USDA to predict the impact on environment of land use, land management practices, and climate change. And it simulates the water quantity and quality in a watershed. It is composed of two phases: the land phases, which calculates the fluxes and the processes in the land, and then the routing phase that calculates the processes in the water. And the fluxes that are taken into account are water, sediment, nutrients, and pesticides. It's a small watershed to large basin model, and it was used worldwide. And another advantage of this model is that it's well documented and it has an open source code, so we can modify it according to our objectives, and it's constantly improved by the modifications of users. In SWAT, the in-stream processes are represented by a module that is adapted from the Qual2E model. And you can activate it or choose to deactivate it if you don't want to represent the biogeochemical processes. And this model represents the main processes, but just for nutrients, and doesn't take into account other variables like organic matter and more complex processes, more different processes like denitrification, that are important for nitrate removal. And some studies also show deviation from observed data. That's why we wanted to improve that part, and we thought about incorporating the RIVE model in SWAT, which is an ecological model that, at the contrary, has numerous chemical and biogeochemical processes and variables that are representing, like 3 classes of phytoplanktons, but also zooplankton, bacteria, and organic carbon. And it doesn't require calibration, as the kinetics were established based on a lot of experiments. This model is often used with an hydrological model, for example, in reverse Strala. And this model has a 10 days resolution, and the inputs are mean values, and doesn't take into account all the processes in the land. That's why we choose to couple the two models and not just use RIVE alone, because SWAT had the advantage of good processes represented in land. So the idea is really to replace the qual2e module in SWAT by RIVE module, and to keep everything else in SWAT. So this will allow no calibration for water quality, and this will we will have the representation of organic carbon in the channel and processes like denitrification, which are important for my objective to study the regulation zones and the removal of nitrates. So to do that, we first about the temporal and spatial resolution. So to see if it match, for the spatial resolution, there are no particular problems as RIVE is adaptable. But for the temporal resolution, RIVE is better when the processes are calculated every 6 minutes or 10 minutes, but we will have to run it several times a day. And then the outputs will be SWAT daily outputs. Another problem is the inputs of RIVE are the fluxes from the land, and in SWAT they are calculated for nutrient, phosphorus, nitrogen, phosphorus, and suspended solids. Their concentration in the surface runoff, lateral flow, and return flow is given, but they are not the concentration of organic carbon and silica that are required for RIVE. So we will have to estimate this. We can do this by equation, like the equations of FAB or biogeochemical. And then another part is also to put this in 3 classes, because it's what RIVE required, 3 classes of biodegradability. And we can use the percentages that were given by Villemain. Yeah. And then for the silica, the solution we encountered, what's already done for RIVE is to estimate from lithology for the dissolved silica and to use a mean content for the biogenic. So it's less precise than what SWAT gave, but for now it's what we have. Maybe we'll improve that. The other inputs for RIVE are point sources. This will not there will no problem, because SWAT already takes into account the point sources, but we will require to add the variables that are not in SWAT, like organic carbon, silica, or bacteria, will need to be had. And the third problem is that in RIVE, there are a lot of biomasses that are taken into account and not represented by SWAT. So we will have to put initial concentration, and by literature measures or equation linked to variables we know we have the data for. And this for the water column, and for the benthic variables, they usually use in RIVE the coefficient multiplied by the sediment content to initialize the variables in all the channels. And so the methodology I'm going to apply is first to test RIVE on one segment of the Toulouse-Malloz, of the Garonne watershed, which is the part from Toulouse to Malloz. We showed that part because we have data on the Garonne watershed, and SWAT project was done. Because first I had to do that on the Vienne watershed, but none of that was, I didn't have none of that. So we showed the Garonne for first. And then if the results of RIVE are consistent with in this watershed, we will implement it, integrate it directly in SWAT code. And we're thinking about SWAT plus code, which is a a revised version of the SWAT and is more flexible, as a more flexible spatial representation. So we're going to implement it directly in SWAT Plus. And then we're going to test it on the whole watershed and on the Vienne watershed, which is the watershed I'm studying. So I don't have results, but we can see here the results on the SWAT results on the Garonne. So the comparison between values with qual2e and no qual2e. So they are close to the observation, but it's also due to the calibration that allowed that. And with that RIVE, we won't have that calibration part, so we can focus on the processes and analyze the problems like eutrophication more easily. So we will have more detail. The processes will be more detailed and not just phytoplankton attack like in qual2e. So the conclusion of this presentation is that the coupling will allow a final representation of in-stream processes, no calibration, and to take into account other variables like organic carbon, and to study other processes more precisely like denitrification, in-stream denitrification. But on the other hand, it requires a lot of data that we don't have and we don't need for SWAT, like zooplankton biomasses or bacteria biomasses, and to add other inputs that are not calculated by SWAT. And maybe the calculation time will be higher as RIVE has to run several times a day for daily inputs, daily outputs. So thank you for your attention.
Okay, thank you, Sarah. We have plenty of time for questions. Next talk won't be for about 10 more minutes. So are there any questions?
I got a question. Why did you use SWAT and not SWAT Plus to begin with? Because SWAT Plus has a different code base, so I would expect there's going to be maybe a lot of extra work to go finally to SWAT Plus if you already have done SWAT. And the other question is, how long did it take you to integrate, and did you use any kind of methodology, standard API, or how did you perform the integration? And can you somehow quantify the level of effort to do so?
For the first question, we first SWAT because everybody was working on SWAT in the team, and we had all the resisting SWAT, but we thought this summer to switch to SWAT Plus, and as I'm beginning the implementation, I'm going to switch directly to SWAT Plus. So first, my reflection was on SWAT, but I would go directly on SWAT Plus. And I'm sorry, I didn't hear well the second question.
Yeah, it's just give us an idea on what it took you to integrate both models. And did you use any standard or any API or any more structured way of integrating both models above and beyond just putting the code together?
I'm sorry, I can't hear you. I'm gonna put my volume higher.
Sorry, let me. Did you use any formal method of putting both models together, and what was the effort? Can you quantify somehow the time that it took to integrate both models?
I'm still working on it, but more time than I thought, because yeah, first I need to understand both models, and there are some issues that I haven't seen first, so I don't know how many times, that's a lot. And because also first Rive was not coded in the same language as SWAT, so I had to switch the language to implement it in SWAT also. And I still haven't finished it to link really the models.
Well, I would also like to comment on the SWAT Plus that I think so far there haven't been too many tests and applications on the water quality. So that it's maybe also wise to wait a little bit before switching to SWAT Plus in case of water quality studies.
Yeah, but we talked with the creator of the SWAT Plus, and they told us that it's better if I'm just beginning it to directly code it in SWAT Plus, as it will be used after more than SWAT. Yeah. And for all the improvement, it's better to directly code in SWAT Plus.
Yeah, for the long term, it's better, but in the beginning, you may have some.
Yeah, for the tests, maybe SWAT.
Yeah, we've run some water quality simulations, and I think the sediment part is going quite well. But for the nutrients, I'm not sure it's all very tested. Yeah.